Hi guys, today I'm going to discuss the most awaited round by tourists, for which everyone was thinking that it would be quite hard. But the problems A, B, and C were pretty like Div 2 only, or rather a bit easier than Div 2. And D was pretty much, rather, D was also not that much DSA based and required only simple observation and implementation, constructive algorithm, you can say. So basically in C it was pretty easy that you have to find the number X number of stages after the n stages have been passed, so that after these n stages the player one's the score is at least greater than equal to player 2 score theoretically. So basically suppose till this point of time k stages have been completed and the player 2 score is greater than player 1. So after some say x number of stages, if the player one's score becomes greater than player two's, then that x is our answer. As we could take 100 for player one always and 0 for player two always, as we need to just make it theoretically greater. So let me do it here. So now suppose I take the sample test case only 20, 30, 40, 50 and 100, 100, 100, 100. So basically total till now 4 stages have been completed. So 4 minus 4 by 4, it comes out to be 3. So last 3, as I would be firstly sorting it, so 50, 40, 30, 5, 4, 9, 5, 4, 9 plus 3, 120. 120, and this comes out to be 300. And you would eventually see that after 5 stages and 6 stages, the condition is not satisfied. And after the 7th stage, what would be my this value? 7 minus 7 by 4, this comes out to be 1, 6. So 6 stages, I need to take 6 values, and total 7 stages have been completed. So here it would be having 300s, and here it would be having 3 zeros. But I need to take 6 maximums. So 300 plus 50, 40, and 30. This comes out for player one, and for player two, it comes out to be 100 into 4 plus 2 into 0. This comes out to be 400. So I can definitely see that the player 1 score is now greater than player 2, and hence 7 is the total stages. So our answer X would be 7 minus 4, which is 3. So basically you could eventually see here is that if suppose after let's call this value 7 as our answer M. So if you could see that after M stages, no matter how many stages you add, this value would definitely become bigger. This 420 value, this would definitely become bigger because we are taking 100 for this and 0 for this. So if our answer exists for the value m, then our answer always exists for value greater than m, and hence we can definitely see that the condition of binary search is can be easily applied, because it follows like this. Suppose our answer exists till here, then I can definitely say that the answer for all these values also exists. So basically the condition is somewhat like this: false, 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 then true, 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 true. So I need to just find the first true, and here my explanation just got completed. So let's get to the VS Code and see the actual implementation. So here we go. Firstly, I would be just taking the simple test cases, and then here our actual logic goes. I have defined the array A, that is for first player, and the array B, that is for the second player here in the global space. And then it's just the input, and then I would be just sorting it. And then this is just the basic, what I can say is the binary search limits. The minimum would be n, and the maximum I just took it up to 1e16 because I didn't care. As in binary search, it doesn't take a lot of operations. At max, it would take approximately 61, 62 operations. So it's fine. So I'm just checking this. So if this is the check function, which I would just show you, and if this satisfies our answer, then firstly I would store that answer, and then I would just decrease the range to left side. And if the answer comes out to be false, then I would increase the range to the right side. As and I am not taking the minimum value, because every time I would be shifting the range to the left side, so the answer would definitely come out to be minimum. So I can't just directly store answer is equal to mint and just directly on the output this value. and basically here is the check function. This logic could also be implemented in just o of log n by using prefix sums also, but since n log n approach is also fine and would not result in a TLE, so I just didn't bother to do that. Basically here this is just the basic implementation, nothing very hectic type of thing. This is just the value that needs to be calculated, and this is the sum for the what's the name of the second pair, Ilya Shah. So I would just add the values for it, and this I'm just taking n minus minimum of nk because k could be a very large quantity also. And this add value calculates how much I need to add 100. So this is just k and mid minus n, so minimum of that, and then after that I would just add the values in the array A, and then if the player 1's value is greater than the player 2's value, then I would just return the answer, and if this comes out to be true, then this would get evaluated, and here the question gets completed. So let's now move on to the question D. So now here we come to question D, Secret Santa. So basically by the problem statements, you could analyze it like the problem based on graphs, but after thinking for a while, you could also see that it could be solved by greedy methods. So I would be discussing that greedy method because the graph method is literally very complicated. I thought it for a while and then got an idea, but wasn't able to implement it. So clear the screen first. And let me tell you the problem statement first. So basically, there are some n employees, 1, 2, 3, 4, and they all want to give some present to any other employee. Suppose the first employee wants to give, let me take the first test case only so it would be easier for me to explain. 2, 1, 2. Okay. Okay, yeah. 2, 1, 2. So basically, the first employee wants to give gift to employee number 2, the second wants to give gift to 1, and the third wants to give to 2. So basically, after the end, I need to construct an array where each employee gives a gift to a different employee and all the employees are covered. And pertaining to that, this initial conditions maximum values are met. Let me explain it by example. Suppose this is the initial condition, this is employee 1, 2, 3. Finally, I suppose I give a permutation of this like this. So now here 1 gives gift to 3, 2 gives gift to 1, 3 gives gift to 2, and the number of pairs that are matching is this is matching, this is matching. So basically total 2 pairs are matching. So now what I'm claiming is that the total number of pairs which are matching initially in this array, the total distinct elements which are present in this array initially, is the answer for the first value of our answer, this value. And how could I say that? Let me explain you. Suppose if any element's frequency is just one, suppose any element is coming for just once, this one is coming for just once, so no problem, this would remain as it is. But if any element is coming two or more than two, so that the frequency f is greater than equal to 2, then what I can say is that I would just let it to be at one position, but exchange the another position with any other employee, and I would definitely be able to find such employees for every element's frequency, for every element whose frequency is greater than or equal to 2. And this is because I just need to also check that for any employee this condition is not met, like the employee number 3 gives gift to employee number 3, because why would one gift give a gift to himself only? So this is the implementation part now only which is left, and this part can be implemented in many other ways. Suppose let me tell you a one way which I implemented through. So suppose basically I would store all the indices of the element which is coming. So the 2 is coming at position number 1 and 3, and the 1 is coming at position 2. So left are 1 is used, 2 is used, left are 3, which could simply be this 3, and the left part which hasn't come in the initial array could be easily developed by a Boolean array. and then after that I would just check this 3 with this one. If it's not matching, then I would just write 1 as 3 and then would erase. And if the number of elements in this is just 1, then so there is no problem. Otherwise, I would move it continue. So what I could prove is that suppose my 2 was coming at in an example at 1, 4, and 5, and now I need to assign 4 and 5 also. So then what I can definitely say is that I would definitely find any two values which are not same. Suppose I could match 1 to 4 and 4 to 5, and this 2 and 5 would remain intact as in the original array. So I could definitely form this logic and could answer that greedily. Now let me show you the implementation. The implementation, I am again saying, could vary for everybody quite a lot, but here I am showing the my way. So here I am just taking the test cases. This is just the input, and then I'm just taking this kind of map that would store all the indices of any element which is coming in the initial array. And this I am using a boolean array to find which elements haven't come in the initial array. So I would just basically initialize all the values as false, and then which values are coming, that would be definitely true. And this is the vector where I would be storing all the values which haven't come in the initial array. So here this is that condition. This not operator just to check that if the given element is having false in it. So this cout mb.size is that only number of elements which are distinct in the initial array. So now here is just that the part that the same value should not come at that same position. So here I'm just taking this storing the size, the number of indices, the size in the value m. If the size is 1 only, then I don't need to worry because that's the position already satisfied. And then this flag value is useless. Okay. Uh, then I would be as if for any element, suppose for 2 I was having 1, 3, and 5, then I just need to change two values, and for one value it needs to be remain intact, and hence that's why I'm just initially doing m minus 1, and then till the number of elements are left, I would be just iterating over these ranges. And if the first if that is not equal to range, then I would just insert that element, okay, assign that element in the array, and then I would just break for this value. Then this loop would again run, again run, again run, again run, and I would be erasing also if I after I found it. And you could also see that this loop would run only for 2 times, because let me show you this also. Suppose the indices for 2 was 2, 1, 3, and I needed to find 3. So if it doesn't matches, then so there is no problem. But if it matches, suppose it was like this 3 and 1, if it matches, then I am damn sure that after the next element it would definitely would not be matched, and I would be just breaking this loop. So at most this loop would run 2 times. So basically this loop is nothing but just you can say O of 1 operation, and this whole combined two loops is O of n. So basically this solution is O of n only. And then after I just store all the values, then I would just simply output the answers. Then I'm just let me run it also to show you that it's working. And here we got this. This is pretty fine. So hope you like the approach.